Great, so sorry. So this is our September webinar. We're here with Ciaran Evans and Will Cipolli. So I'm just Lee Johnson. I'm the host and moderator. I'm out of Columbus, Ohio at the moment. I have a little bit of issues with my internet, so if I suddenly drop out, that's why. All right, so just a couple of things. Our next webinar will be with Lee Kennedy Schaefer from Vassar College. That'll be October 17th at 4 p.m. talking about their article, Teaching the Difficult Past of Statistics to Improve the Future. So please look for an announcement for that shortly and sign up. So a couple of things happening with CAUSE. The Electronic Undergraduate Statistics Research Conference is currently being planned. It's planned for November of this year. They don't have a final date yet, but they do have a keynote speaker, the director of the U.S. Census Bureau. So definitely if you want to get your students involved, stay tuned for exact dates and links and that sort of thing. And then, of course, if you haven't heard already, ECOTS will be happening next spring, our electronic version of USCOTS. So that's May 28th through May 31st, sorry. And there's some of the deadlines there if you are thinking about participating. The first one is December 30th for breakout sessions, workshops, and reading groups. And then right after that on January 1st, a deadline for activity contests and so on. All right, so we'll keep posting those and encourage you to participate in that. All right, so just a quick introduction to both of our speakers, and then I'm going to turn it over to them. So Ciaran Evans is an assistant professor of statistics at Wake Forest University. He's interested in statistics education and pedagogy and enjoys collaborating with other educators on teaching and research. And Will Cipolli is an associate professor of mathematics at Colgate University. He was the 2020 Waller Award winner in recognition of his innovative approaches to teaching and statistical collaboration, bringing the importance of statistics to daily life, to his students and others, and for his tireless work to reform statistics education at his own institution and beyond. So I am going to go ahead and stop sharing my screen so that our presenters can go ahead and take it away.
Cool. So I'll start. I'm just going to share my screen and get the slides up. I know it says I'm Ciaran, but I'm Will. And so let me go ahead and put this into slideshow mode. There we go. So today we're going to talk about a little bit about the motivation. The goal for us is to kind of talk about the full data analysis lifecycle. We have this wonderful illustration from Allison Horst, sort of demonstrating all of the different pieces that go into that the life cycle of answering a question using statistics. One of the things that we'll explore today is sort of integrating real data with a context and purpose, sort of that recommendation from the GAIS guidelines. And so one of the things that we want to look at is leading students through some real data and using that data to get them to think about ethical issues associated with doing statistics and sort of setting up a quantitative experiment, collecting data and using that data. And to do that, we're going to use a data set that's really relevant to students. This is a data set from the psychology literature where they look at the effect of canine interactions on students' well-being and ill-being. And the nice thing about that is it's really relevant to students' experience. They know what it's like to be at college and know what it feels like to need an increase in their well-being or to sort of make that adjustment from home to college life. And so part of that is thinking through the experiment and all of the different variables that are selected. So the data that we're going to look at, it's 284 students, and they're selected from a Canadian university, a mid-sized Canadian university. The students are randomly assigned to one of 3 treatment groups. Ciaran did a great job of splicing some XKCD comics together to give you an idea of what that looks like. They have handler-only contact, which is the students meet with the dog handlers, just a person-to-person interaction. Indirect contact, where they meet with the handler and the dog, but they're not interacting with the dog physically, like playing with the dog, things like that. And then direct contact, where they meet with the handler and the dog, and they're allowed to pet the dog, make physical contact, play with the dog. so on and so forth. The researchers used a variety of well-being and ill-being measures, and there's a pre-post design. So they measure, one of the things that we'll look at in a second is stress levels. They measure it before and after. So there's this pre-post design. And their approach is they want to sort of check what changes occurred between the before measurement, the treatment of interacting with a person or a dog in some sort of way, and what effect that has on the after measurements of those well-being and ill-being surveys. So the 9 different outcomes they looked at range from positive affect, negative affect, stress, happiness, connectedness, social connectedness. And these are the things they're trying to evaluate whether interacting with a dog has an effect. They also collect demographic information, including gender, male, female, non-binary. And one thing we note in the JSDSE papers, these sort of align more with sex than gender. They also collect ethnicity, and they had a lot of options available, and students could select multiple options: age, year in school, and major. And so there's lots of information available. The nice thing is that a lot of this is accessible to students. They are students. They kind of have an idea about demographic information from just being a person. And a lot of the outcome measurements are things that, you know, humans, whether they have taken a psychology class or not, are at least thinking about. And so the statistical methods they use paired t-tests, sort of that pre and post test measurement. And they also used regression to sort of see the effect of the treatment across groups. And so what I'm going to do is I'm going to break away from here, and I'm going to go to, this is a data science collaboratory app. So one thing I'll point out is there's a list of them on the resources page here. We're going to use the regression app, and I have it set up to do one of those treatment effects. Here we're looking at predicting the post-treatment stress measurement, and we're going to predict that controlling for the pre-treatment measurement and the group assignment, what treatment group the participant was assigned to. The convenient thing about using a Shiny app is that you can do a lot of analyses that might not be possible in Excel or using a TI calculator or some other technology. So the idea is it allows you to sort of skip coding in R, but get all the benefits of using R. So students can sort of look at those pairwise plots. They can assess the assumptions of regression, the normality, whether or not there are any outlying observations, using things like leverage and Cook's distance. And then you start looking at the ANOVA tables for regression. The nice thing is a lot of the interpretations are made. So even if you're teaching an introductory course where they're sort of interpreting statistics that are made available to them, this sort of technology allows you to tackle these more complicated problems. And you'll notice that it also does the factor comparisons to compare the different treatment groups, and also provides the overall regression model. And so this is one way of incorporating these data into the classroom at the introductory level, and at the more sort of intermediate and advanced level, students can do this R coding on their own. So with the end of this, I'll introduce you to Ciaran, and he'll talk about a few more uses for the data in class.
Awesome. Thank you so much, Will. I'm just going to go ahead and switch over to the slides here and share my screen. And again, put that into selection mode here. All right. So as Will's gone through, this data set can be used to teach a variety of statistical methods that you might cover in a first or second semester stats course. And in the JSDSE paper, we talk a little bit too about teaching students some of the data preparation and the data cleaning. If you give them some of the raw data, there's quite a lot of manipulation that needs to be done to actually get out those pre and post treatment variables. You've got to do a lot of sort of transformations and summary statistics and so on to combine all of the Likert items into these 9 well-being and ill-being measures. So there's a lot of opportunities there for some of the sort of the stats topics that you might teach in stats courses here. But in addition to thinking about some of those statistical methods, I want to think about some of the discussions you could have around this data as well, and the way that data is collected and the way that it's used, and in particular in relation to demographic data and identity and privacy and ethical issues surrounding some of those. To motivate this, I want to think about a question that I've had actually from several students, and I think is a pretty natural question when working with this data, which is, well, why do we need to collect all these demographic variables? The analysis that Will showed and the analysis that the researchers do in the original paper involves really the well-being and the ill-being measures and the treatment group. And it's a randomized controlled trial here, so you kind of don't need to include some of these other variables, which is kind of the point of randomization. So students ask, well, why do we collect all this demographic information in the first place? It takes time and it takes effort, and they're kind of personal questions about the participants. So if we're not going to use them, well, what's the point? And there's a few potential reasons, and I've listed a couple of them on the screen here. And honestly, I think probably the best response for students is that you want to assess the generalizability of your study, right? You do this study, you want to know what population your results are going to generalize to, so you need to describe the group of students who have actually participated in the study. Now, this is an important part of the results here, but the demographic information, things like age and gender and ethnicity, is still kind of personal, and it's important to think about any potential issues that might be involved in collecting this demographic data. To illustrate why there might be some issues with collecting or sharing the demographic data here, let's take a look at the table of demographic summary statistics. This is table 1 in the original paper that I've reproduced for you here on the slides. Students in a first semester course should know how to calculate all of these numbers. They're just means and proportions and standard deviations. And to emphasize reproducibility, which is one of those topics that statisticians really like to talk about when they teach data analysis, I might ask them to recreate this table given the study data. Now, they might not be able to make it look quite as pretty as this, but they should be able to calculate all of those numbers that you see here. But if you look at the table, you'll see that there's quite a few groups that only have sort of 1 or 2 participants in them. So for example, one of the nice things about the studies, they do actually ask more than just a sort of male-female gender question here. They allow other and non-binary as possible responses, but only 4 of the respondents have selected something other than male and female. And if we look at ethnicity, there's only 1 student who selected Italian, there's only 1 student who identified as Japanese, only 1 student who identified as West Asian, and so on. And this quickly causes problems with identifiability in the data. So for example, if I knew a student who identified as Italian and as non-binary, and I happen to know this student attended a mid-sized Canadian university in the last few years, and maybe they took a psych class, so maybe they were kind of primed to volunteer for these kinds of studies, you could potentially link them with the full data to their well-being and their ill-being measures. And then you'd know about how they were feeling at this time, and that's sort of crossing a boundary with their personal information. Table 1 by itself doesn't violate this sort of privacy, because all we have are the marginal summary statistics within each of the treatment groups. But if I had the full data, which is what I would need to reproduce table 1 and then do the subsequent analysis that Will was showing you, then we've got some pretty serious privacy concerns. Now, that the data that Will was showing you does not include all of that demographic information. We're just looking at the outcome measurements in the treatment groups, and so there's not the same kind of issues. We're not linking the demographic data to all of the outcome measurements, but if I did have that full data set that the researchers collected, there might be some issues with anonymity here. So we see this tension between several important goals, all of them really laudable, this idea of reproducibility and describing the study population, and also respecting participants' privacy. And you can't have everything perfect. You can't do all of those things perfectly because of the sort of sensitive nature of some of the data here. And you can imagine lots of other data sets that have the same kind of restrictions. So this relates to topics like k-anonymity, and I've put a couple of references here on the slide for you as well, which have some more in-depth discussions about privacy and some other issues in data and ethics. One of the chapters, for example, in Modern Data Science with R, has a good discussion about several ethical topics. They give the OkCupid data as an example as well, with sort of similar issues with privacy and identifiability and so on. In addition to thinking about reproducibility and identifiability here, you can also use the demographic data to have some good conversations about how we collect data and how we measure identities and how we use this information. So for example, we could think about how the variables here might be recorded differently in Canada versus in the US. This was a study that was done in Canada, and so it's going to be influenced by the local context in Canada. We can also think about how specific levels of these variables were selected by the researchers. And again, you have this tension between sort of what's useful and usable for statistical analysis, but also trying to accurately capture participants' identities. And this is tension again between, you can't sort of have everything perfect and sort of meet all of these goals perfectly. So there's going to be compromises involved in data analysis and data collection, and that's a sort of important conversation to have with students. Finally, I just want to finish up by mentioning one other ethics discussion that you might have, another sort of topic in ethics, slightly different from some of the identity questions that we've been discussing before, this time with multiple testing. So in this study, you've got 9 different outcome variables. You've got the 9 different well-being and ill-being measurements, and you've got 3 treatment groups. So you're going to have at least 27 different hypothesis tests if you're comparing the pre and the post-treatment measurements for each of the 3 treatment groups, and you're doing a sort of simple 2-sample t-test. If you're doing other hypotheses that they tested in the paper, then you're going to have even more than 27 hypothesis tests. And this is a nice example where you actually do legitimately have lots of hypothesis tests for valid reasons that you all want to test. You're not just sort of p-hacking your way to glory and finding that one p-value less than 0.05. You do legitimately care about answers to all of these hypotheses. So you're not just sort of trying to find the one significant result. So this gives a good opportunity to discuss some of the challenges with multiple testing. And I like the XKCD jelly bean comic to sort of illustrate this as well. As you can see, there's sort of an XKCD theme going through here. And it's sort of a jumping off point to have some of those discussions and to introduce some tools to control things like the family-wise error rate, like Bonferroni corrections and Tukey's on a significant differences and so on. So the data set that we've talked about today, it gives a lot of good discussion points that you can have with statistical methods, with 2-sample tests, with false discovery and false family-wise error rate control, with the regression, but also thinking about data collection and data cleaning and data processing and sort of the whole data analysis process that Will was talking about at the beginning. You can really have a conversation about that whole process using this data set. There's more details on all of the things that we've talked about today and a few discussion points that we haven't brought up as well, just for reasons of time, in the JSDSE paper. And that paper was joint with John Tyler Benfei and Zach Draper, who were part of the original research team that collected this data and published the original paper. We'd like to thank them as well for collaborating and sharing this data with us and working together to think about how you can teach statistics and some of these concepts with this data set. Thank you all so much for attending our talk, and we're happy to take any questions.
Yeah, so give everybody a minute here. You can either put them in the chat. There is a question and answer feature on Zoom that you could also ask a question on. Will say I personally am a huge XKCD fan. I actually have the jelly bean one on my door. So that one's a fun one to do.
They had a great one recently with calculus and sort of the paths through integration versus sort of differentiation, and how one of them is more difficult than the other, that I was using the other day to sort of explain why it's nice if we have distributions where we sort of know how the derivatives behave versus having to sort of integrate to find expectations.
Good. I don't see anyone. We've gotten several clappy hands, of course. Again, you can all see the chat there, but just basically thank you for such a great presentation and article and wonderful application for interest stats and other courses. We appreciate the webinar organizers too. I appreciate that. Have a great week and a month until the next one. Are there questions? So my only question was, did you find it difficult to settle on an article? And do you have other ones that you've kind of picked up as you've been doing this that might be good for some of these related topics? Obviously, this is from psychology, you said.
Will and I have talked about a couple of articles, and I've also done a couple sort of related things with other articles for different topics. So in addition to this data set, Alex Reinhardt from Carnegie Mellon shared with me another psychology data set, sort of looking at group diversity and group composition that I've talked about sort of previously. There's a link to that data set in the sort of cause and JEDI resources, in addition to this one here as well. That's good for thinking about things like interaction terms, but also, again, measuring sort of group identity and so on, sort of having some of these sort of similar conversations. And if you're not able to find that on the JEDI resources, if you shoot me an email, I'm happy to share it. Alex has it posted on a CMU website that's fantastic for other data sets as well. I also have a JSDSE paper from last year talking about a marine biology data set that's kind of fun for thinking about mixed effects models and so on. Completely different kind of conversations that you might have, but you know, I think it's kind of interesting. Will, do you have other data sets that you like to work with?
Yeah, so another data set I work with is a 2016 paper, Bracht et al., B-R-A-C-H-T. And they look at using MFAP4 as a biomarker for fibrosis severity in hepatitis C patients. And so it's a biological application. But the authors publicly posted their data as part of the publication, and they've been really great about emailing back and forth with questions. And it's something I want to reiterate our thanks to John Tyler Benfei and Zach Draper for responding. I think it all started, I was writing an exam and I was trying to get an interesting data set to prompt my students with. And 99% of the emails I send to researchers looking for their data or for some information to follow up reading their article, they go unresponded to. So the level of openness and collaboration of these two was really, really helpful in making this happen. And so yeah, so that's what I would say about that. And Ciaran, there was one more webpage that you sent me to that has a bunch of data sets for different things.
I think that was the webpage that Alex has actually created.
Okay, cool.
So yeah, he's got a great CMU repository with data sets that he and other people at CMU have put together that is one of my go-tos when I'm looking for data. So
and it's nice because you can search by method, like if you want to use ANOVA, for example. I thought that was really helpful.
Yeah, they've done a good job with the tags.
Yeah, that's great.
All right. Any other questions, sort of last minute? Anything else? Let's see.
Yeah.
All right. Well, thank you very much for doing this and taking the time to do it. The recording will be posted shortly on CauseWeb. So if you have colleagues that didn't happen to make it and want to see this, please direct them to the webpage. But thank you very much for doing this.
And
one
thing I'll say is if they are watching the recording, I'm totally happy to respond to questions via email if anything pops up or if anybody's shy and doesn't want to ask now. We're happy to share any resources that we have and chat about it more.
Yeah. And yeah, I think both your email addresses are under your pictures somewhere in the slides there. So those will get posted too. And Alex says, thank you for advertising for him. All right. Have a wonderful day, everyone.
Thanks,
we'll see you in
everybody.
October.
Thank you so much.
All right.